All right, let's dive into the world's deserts. And I'm going to make you a promise. By the time we're done here, you're not going to see them as just empty wastelands. You'll see them for what they really are. Incredibly complex, vibrant places that have shaped our world in ways you probably never expected.
Okay, so when I say the word desert, what pops into your head? Is it a scene kind of like this one? Just endless sand, emptiness, maybe a little bleak? Well, I'm here to tell you we need to challenge that idea, because these places, they are anything but empty.
So, let's get right to it. What is a desert, really? What's the one thing that defines it? And here's the first surprise. It's not the heat. Not at all. It's all about one simple thing: dryness.
Scientists actually have a really neat way to measure this. It's called the aridity index. The best way to think about it is like a bank account, but for water. You've got your income, that's the rain that falls. And then you have your potential expenses. That's all the water that could be evaporated by the sun and wind. If the income, the rain, is less than 20% of those potential expenses, well, you're in the red. And congratulations, you've officially got a desert. Okay, so what happens if we take that rule, that aridity index, and map it across the entire globe? Well, you get this. This is our first way of looking at it, our first lens, if you will. It's the purely climatological view showing every single place on Earth that's technically a desert based on that water budget we just talked about.
But, that's just one way to slice it. Let's try a different approach. For a second, let's just forget all the climate numbers. Instead, let's ask a biological question. Where do we find plants that are specifically adapted to survive with barely any water? If you map that, you get this view.
And we've got one more lens to look through. For this one, let's pull back, way back, all the way up into space. From up there, with satellites, we can do something pretty simple. Just map all the big areas that have extremely low vegetation. Basically, where are the bare spots on the planet? That gives us this third and final view. Now here's where it gets really, really cool. Remember our three maps? The climate one, the plant one, and the one from space? What do you think happens when you lay them on top of each other? Well, they match up, almost perfectly. It's incredible. It's like three totally different experts all pointing to the exact same spots on the map, defining this massive, global desert biome that covers almost a quarter, a full 25% of the Earth's land.
So how did these massive drylands even form? Well, it's not by accident. There's a kind of global recipe for making a desert. It turns out you really only need 4 key ingredients to get the job done. And what are those ingredients? First, we have planetary air circulation. Second is something called continentality. Third, you've got cold ocean currents. And finally, mountain rain shadows. So let's break down each one.
All right, ingredient number 1. This is the big one, the planet's heat engine. Think about the equator. The sun is blasting it, right? So all that hot, wet air rises up, cools down, and then just dumps tons of rain. That's why you get rainforests there. But here's the thing. That air has to go somewhere. It moves north and south, and as it travels, it gets colder and denser until it starts to sink back down to Earth, right around 30 degrees latitude. And by that point, it's like a sponge that's been completely wrung out. It is bone dry. And that sinking dry air is the single biggest reason we get those huge desert belts around the world.
Ingredient 2 is a lot simpler. It's basically about how far you are from the ocean. I mean, think about it. That's where most of the moisture comes from. So as winds blow across a giant landmass, say over Asia, they're like a leaky bucket, dropping rain as they go. By the time that air gets deep into the center of the continent, the bucket's empty. There's just no more water left to drop. And that's how you get huge inland deserts like the Gobi.
Okay, our third ingredient is a weird one. It's almost a paradox. It's cold ocean water right up against a warm coast. You see this on the western edges of continents like South America and Africa. Deep, frigid water gets pulled up to the surface, and this acts like a lid. It cools the air right above it so much that the moisture can't rise to form rain clouds. So you end up with one of the driest places on the entire planet, right next to the biggest body of water on the planet. It's wild.
And finally, ingredient number 4, the rain shadow. This one's pretty straightforward. Imagine a big, wet air mass moving along and bam, it runs into a mountain range. It has no choice but to go up and over. As it rises, it cools and it squeezes out all its moisture as rain or snow on one side. By the time that air crests the peak and comes down the other side, that sponge has been wrung dry. Again, it leaves a dry, arid shadow on the other side. That's exactly why you see deserts tucked in behind big mountain ranges.
So you take those 4 ingredients, you mix them together, and you get some of the most extreme environments on Earth. But, and this is the key thing to remember, extreme does not mean empty. Absolutely not. In fact, deserts are home to some of the toughest, smartest, most incredible survivors you will ever find. When it comes to plants, they've got a whole playbook for survival, and it really comes down to 4 main strategies. You've got the hoarders, like cacti, that just store tons of water. You've got the sleepers that go dormant and just wait out the bad times. Then there are the tough guys with waxy, leathery leaves that refuse to give up any water. And my personal favorite, the live fast, die young crowd. These are the wildflowers that literally explode with life after a single good rain, race through their entire life cycle, and are gone in just a few weeks.
And this harsh environment leads to one of my favorite ideas in all of biology. It's called convergent evolution. Just look at these 2 lizards. One's from Australia, the other's from North America. They are not even distant cousins. They're completely unrelated. But look at them. They're almost identical. How is that possible? It's because they were both faced with the exact same problem. How do I survive in this desert and eat ants? And evolution, on 2 different continents, came up with the exact same answer. That's incredible.
And listen, it's not just about the lack of water. The temperature swings are just insane. The surface of the sand can get up to 80 degrees Celsius. That's 166 Fahrenheit. You could literally fry an egg on it. But then, when the sun goes down, that same spot can plunge down toward freezing temperatures. Imagine living through that every single day.
So how do animals deal with this? Well, they've got a whole toolkit of tricks, and they fall into 3 main categories. First, there's behavior. You just hide from the heat, live underground, only come out at night. Smart. Then there's morphology, which is just changing your body shape. Think of the giant ears on a fennec fox. They're basically personal radiators. And finally, physiology. That's the internal stuff. Their bodies are just masterpieces of water conservation, doing things like creating super concentrated pee or surviving dehydration that would kill one of us in a heartbeat.
And some of these tricks are just so clever, you have to smile. Check this out. This is an African ground squirrel. How does it look for food out in the blazing sun? Simple. It just flips its own fluffy tail over its head and uses it as a personal built-in umbrella. I mean, come on, that's brilliant.
But if there's an award for the most mind-blowing adaptation, it has to go to the kangaroo rat. Get this. This little guy can live its entire life without ever drinking a single drop of water. It doesn't need to. It actually creates its own water inside its body just by metabolizing the dry seeds it eats. It's a walking water factory. So yeah, these are clearly amazing places, filled with amazing life. But the story doesn't end there. Their importance goes way deeper, right into our own story. Because deserts and drylands, they weren't just a backdrop for human history. In a very real way, they are the foundation on which our world was built.
I mean, just think about it for a second. When early humans started domesticating animals, which ones did they pick? Goats, sheep, donkeys, camels, llamas? What do all of those have in common? Their wild ancestors were all tough-as-nails survivors from dry lands. We didn't pick the easy ones. We picked the ones that were already adapted to the harshest places.
And it's the exact same story with plants. The absolute cornerstones of agriculture, the plants that fed the first cities and empires. Where did they come from? They were domesticated from dryland plants. Remember those live fast, die young wildflowers? Well, that strategy of growing super fast and making a ton of seeds, that is the perfect blueprint for a crop like wheat or barley or corn. The DNA of our civilization has desert roots.
So when you put it all together, from the global forces that create them to the absolutely ingenious life that calls them home, and their critical role in our own human story, it's clear deserts are anything but empty. They are complex, they are resilient, they are vital. They literally handed us the building blocks to create our civilizations. And that leaves us with a really important question to think about. Deserts helped build our world. So as we build our future, how are we going to shape theirs?